Okay, so we're going to move on to our second day of graphing systems. And today we're going to find that most of our systems are not in slope-intercept form. They're not y equals. We're going to have to solve for y and graph from there. So to start us out, we're going to do a little bit of review on how do I solve for y, just to make sure we are good on that. Because if we can't solve for y, it's pretty hard to graph lines. Okay, so starting with solving for y, remember I always move the x by adding and subtracting and then divide by the y. So this is a positive 5x, the opposite is a negative 5x. So this is gone. The negative 3y is going to drop, make sure you don't lose that sign. And remember, these two are not like terms, so I am going to just bring them down, and the x has to go first because it's variables before numbers. Now I'm going to divide 3 times. So 3 divided by 3, that's gone. Negative 5 divide negative 3. Well, negative 5 divide negative 3, I know, is going to simplify. And so is negative 15 and negative 3. So I'm going to go ahead and pull up here my Desmos calculator so that we can look at this together. So hopefully you already have yours up and ready to go. Okay, so let's take a look at negative 5. Negative 5 divide negative 3. And I'm going to go ahead and get rid of some of this here. So negative 5 divide negative 3. Negative and negative is a positive, so I know that that's going to change. Remember, this little button right here is the one that converts it to a fraction. So I see that negative 5 divide negative 3 becomes a positive 5 over 3. A positive 5 over 3. So I'm going to go ahead and make that positive. And now I need to do the other one. So negative 15 divide negative 3. Negative 15 divide negative 3. And I want to know what that is. Well, that's 5. So that must mean it's positive. So positive 5. Okay, so plus 5. So that's done now. So I have my slope and I have my y-intercept. And if I needed to graph, I could. Okay, let's look at the next one. So the next one, I see my order's a little different. My y is actually first and then my x. So I need to move the x. So the opposite of a negative 3x is a positive 3x. So I'm going to add 3x. This is gone. 6y drops. Remember, these two are not like terms. They are going to drop. That's step 1. Now I'm going to divide by 6. 1, 2, 3. Gone. Okay, let's use our calculator again. We need to simplify our fractions. So I have 3 divide 6. I'm going to change that to a fraction because I need the slope in fraction form and not a decimal. I see that I get 1/2. So we get 1/2 x. And we're going to do the same thing with the 12 and the 2. So 12 and the 6 divided by 6 gives me a 2. So I know that my next piece is a positive 2. Positive 2. Okay, so let's go ahead and see if we can solve these for y and graph and find a solution. All right, so let's start with our blue one. So I know I'm solving for y. I'm going to subtract my 2x. I have y equals negative 2x, and that's a positive 2. Now I'm done because I don't need to divide by 1. I mean, there is a 1 here, but I don't need to divide by 1. It's not going to change anything. So the slope, remember, it has to be a fraction, so that's negative 2 over 1, and the b is positive 2. So remember, our slope has to lie on the y-axis, or our y-intercept has to lie on the y-axis. So the first point has to be on the yellow line. So positive 2 is here. And since this is negative, that means I'm going to go down and to the right. 1, 2, and 1. And I'm going to do that a couple of times just to give myself a good line. I'm going to go the opposite direction. So I can see I have a nice line started there. And then I'm going to go ahead and See if I can graph that. Draw that line. Grab the line and move it, not the picture. Okay, that's pretty good right there. Okay, let's do the other one. Now, I need to remember that on this next one, I see that this is a 1, and that's a -1. So that -1 is important because I need to not lose that. So I'm going to move the 1x by subtracting. So I have -1y equals a -1x plus 4. And I have to divide 3 times. -1, -1, -1. So y equals negative, I know is positives. That's positive 1 over 1 minus 4. So here's my b, and there's my m. So I'm starting at -4. That's down here at the bottom. Now this time I'm going to go up 1, right 1, up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1. And you can see my line crossing again right where I can see it on another point. All right, so what is my solution? Where is that solution? Remember, we're looking for the point of intersection. So I'm over 2, and how far down am I? I'm at -2. So I'm at right 2, down 2. That gives me my ordered pair of an x and a y. And remember, you can also find it by finding where the 2 lines cross. Okay, so if I follow these up, the numbers I need are those 2. Okay, let's try this one. I see that I have to do some more solving for y. So what am I going to move on this first one? You're right. I'm going to move the -2x. Well, the opposite of a -2x is a positive 2x. So I have y equals 2x minus 6. So my b is -6. My m is 2 over 1. So -6 is down here at the bottom. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. I'm going to keep doing that a little bit. Go the opposite direction and make my line. Let's see if I can get a decent line right there. Yeah, that didn't turn out too bad. Okay, let's solve the other one for y. So this time I see that there's a -1x. So the opposite of -1 is a positive 1. And remember, you got to move the x first. So no matter where it is, it has to get to the other side. So 2y equals, because those are gone, 1x plus 5. Now I'm going to divide by 2. So y equals 1 over 2x plus. So I've got 5 halves. Well, I probably need that as a decimal because I have to graph that. So if I take 5 divided by 2, I see that that's 2.5. Okay, that's 2.5. So this one is definitely going to be an estimate because it's pretty hard for me to graph middle points and make sure that I'm exact. So we're going to go ahead and just put the point and see what kind of estimated answer we're going to get. So 2.5 is halfway between 2 and 3. And I'm going to go down 1, which means I'm going to the middle, and then right 2, and then to the middle, and right 2, which is going to put me here. Okay, so I am here. So I have a point kind of coming through the middle here, which is going to force us to have to estimate what our solution is. So graphing is always an estimate. It's our best guess when we're graphing by hand. There is no way for me to be absolutely certain that that is going to be, if it's in the middle of something, a true point. So we're going to find out as we move forward that technology can kind of help us with that to be able to find the exact point. Okay, so let's see if we can figure out where we are. So I see that that point is between 3 and 4. So I'm going to call that 3.5 because that's in the middle. That's my best guess. And if I move up, I am going to assume that that is a little more than half between 0 and 1. Okay, so between 0 and 1, I'm a little bit closer to 1, maybe like right there. So I'm going to call that 0.7. Okay, and again, this one is definitely an estimate because I'm in the middle. As soon as I have an intercept of like a decimal, I know I'm going to be making just an estimate, a best guess to try to figure out what is closest to that intersection. Okay, let's take a look at these two. Well, so the first thing I'm noticing is that these have similar numbers. So I wonder if something interesting is going to happen. Let's find out. So I'm going to graph the blue one. I'm starting at 6, and I'm going up 2, right 1. I'm going to go down 2, right 1. I'm going to do that a couple times. And I'm going to go ahead and graph that line. So my line is coming up. Again, it's heading in a positive direction. Let's go ahead and graph the other one. 2x minus 4. So minus 4 is here. And 2 and 1, 2 and 1. I see that these lines are heading in the same direction. And they're not going to cross. Who remembers what these lines are called? Yeah, these are parallel. They never touch. So no intersection. So if there is no intersection, what is my answer? Yeah, this is no solution. Obviously, if I'm looking for where lines touch and they don't touch, there's no answer. So sometimes we come up with parallel lines. All right, let's take a look at this one. So we've got y equals 3x minus 2. Let's graph that one. That one's easy because it's already solved for y. And remember, this is over 1, 1, 2, 3, and 1, 1, 2, 3, and 1. I'm going to go ahead and graph that line. Going to have to twist that one a little bit. You can see how sometimes it's challenging for me to line up the lines here. Okay, that looks pretty good. Okay, let's do the other one. So I have to move my x. So the opposite of a negative 6x is a positive. So I'm going to add 6x. So 2y equals 6x minus 4. I'm dividing by 2. And I come up with 6 divided by 2, that's 3. Negative 4 divided by 2, that's negative 2. Well, look at that. These two are exactly the same. So if I was going to graph this, they would be on the same line. It's the same line. So what do I do? What's the answer when they are the same line? Who remembers? Again, they're the same line. Yeah, the answer is infinitely many. Because they intersect here, 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 here. They intersect everywhere. So since there's more than one answer, that means every number works. So the answer is infinitely many solutions. Okay, so let's take a look at how we actually how we check to see if a point is a solution if we don't want to graph. Because sometimes we don't have a graph and we may not want to have to waste our time solving for y and graphing. So how can I check to see if a point is a solution without graphing? So we've got 3 possible solutions here, and we're going to see if they are solutions. So here is what happens. This is very similar to, and is exactly the same as how we check solutions when we are solving with elimination. Okay, we're going to substitute, and we are going to determine if the solution is true or false. Okay, so I'm going to switch over to purple here to keep them separate, and I'm going to start substituting. So I see that I have a 1 in a parenthesis, a 2 in a parenthesis, and a -2. And I'm substituting in my x and my y. So the x goes first, the y goes second. Okay, so 2 times 1 is 2. 2 times 2 is 4. 2 plus 4 is 6. 6 equals -2. Is that true or false? Well, that's false. If one of these is false, I'm done. I know that this one is not a solution because what I have to have is a true and a true. Okay, I have to have a true and a true. So I do have to check both of them if the first one is not false. Let's try the next one. So 1 times -2 plus 2 times 0 equals -2. Well, 2 times 0 is 0, and 1 times -2 is 2. So I see that so far, -2 equals -2. That one's true. Okay, now we have to try the other one. But this is a y, so there's a 0. 1 times -2 minus 16. Okay, so 0 equals -2 minus 16. Well, that's a -18. That's false. So this one is not a solution. So far, this one didn't work and this one didn't work. So let's see if the third one happens to be a solution or if they're just trying to trick us. So 1 times 4 plus 2 times -3. Again, we're substituting in. So that is 4. And this is a -6. So -2 equals -2. The first one is true. Okay, so I'm going to substitute in the -3 for y. 1 times 4. Okay, well, this is -12. 1 times 4 is 4. 4 minus 16 is -12. So I see those two match. So that is true. So the solution, like I said, has to be true, true. So the only one that has true and true is the 4, -3. Okay, is the 4, -3. Okay, so you're going to be working on some more graphing today. Reach out to us if you're struggling, especially if you're solving for y and really struggling with that. We're going to move on in the next day or so to having technology kind of help us. And we'll see you on the next one.